We need to find the value of this given expression provided omega is an imaginary cube root of unity. So there are three cube roots of unity, 1, omega and omega squared, such that when we take the sum of the root, then 1 plus omega squared is going to give us 0. We'll use this property a little later. Now coming to our expression, what we'll do, we will add the three terms. So we have in the denominator, start with the denominator, 1 plus 2 omega multiplied to 2 plus omega times 1 plus omega. So in the numerator, we will have 2 plus omega multiplied to 1 plus omega, plus for the second term, we have 1 plus 2 omega multiplied to 1 plus omega. And for the third term, we have 1 plus 2 omega multiplied to 2 plus omega. So we will expand the numerator. So let's say in the denominator, we have 1 plus 2 omega times 2 plus omega times 1 plus omega. Now expanding the numerator, we have 2 plus 2 omega plus omega squared plus 1 plus omega plus 2 omega plus 2 omega squared minus 2 minus omega minus 4 omega minus 2 omega squared. There are a couple of terms that will get cancelled out in the numerator. So we have negative 2 omega squared and positive 2 omega squared cancelling out. We have negative omega and positive omega cancelling out. Here we have 2 and negative 2 also cancelling out. So now we are left with 2 omega plus omega, which is 3 omega. So 3 plus 2 will be 5 omega. We have 5 minus 4 omega. So that leaves us with omega plus we have this omega squared plus this 1. So we have omega plus omega squared plus 1 in the numerator divided by the denominator, which is 1 plus 2 omega times 2 plus omega times 1 plus omega. So this will be equals to now omega plus omega squared plus 1. So this is 0. So we have 0 divided by 1 plus 2 omega times 2 plus omega multiplied to 1 plus omega, which is simply equals to 0. So that means the value of this particular expression, that this value is equals to 0, provided omega is a imaginary cube root of unity.